everyone, good day. So once again, this is your teacher friend Liz, and we're back for another exciting topic, which will be our third topic for Mathematics 10 of the third quarter. So right now we will be discussing all about combinations. So last time we have discussed with you guys permutations, how to illustrate permutations, and even solving problems that involves permutation. Now combination is nothing new. It is closely related to permutations, but I would like you to be the one to discover what's the difference between those two. Alright, but first let me lay out what is our learning competency with code. Our learning competency with code is to illustrate combination of objects under the code M10SP-3C-1. What about our content? So this content combinations that we will be discussing today's lesson is still part of our statistics and probability. With the performance standards, the learner is able to use precise counting technique and probability in formulating conclusions and making wise decisions. And the content standard is to demonstrate the understanding of the key concept of combinatorics and probability. So you might have heard of what is combinatorics, guys. This involves both permutations, fundamental counting principle. You can still remember that I have given you activities regarding that one, and as well as combinations. So these three are related to the set of elements on a given set. So it depends on the arrangement. We have special names for those types of arrangement. It can either be permutation or combination. What about my learning objective? My learning objective, of course, it is related to our topic or the title of our module. The learner, or at the end of this lesson, you being my learner, would be able to illustrate combinations of objects. And not just illustrating combination of objects, I also would like you to apply values in it, like making wise decisions or by simply formulating conclusions. But before we get into that, I have here a delicious activity. Even by looking at the image, it makes me feel, I'm getting hungry already. See the image and this food right here? Very beautiful, right? So let's kick into this topic by simply starting with our first activity, or activity number 1, that says, alright, our activity number 1 entitled Recall-ection, because we will be recalling the previous lessons like permutations and fundamental counting principles. So I would like to start my lesson with this activity because I would like to assess your knowledge of permutations and fundamental counting principle, because these skills and knowledge that you have learned in the past, if I am able to dig it up and develop within you the mastery of those two topics, then you will be able to understand combinations better, because that would help you, or that will further help you develop the skills in combinations, and by simply making conclusions, or formulating conclusions, and making wise decisions. So let's start. Activity number 1, recollection. It says here, if your school cafeteria it offers this delicious food. If your school cafeteria offers pork, beef, chicken, and fish for the main dish, chop suey, pinakbet, and black beans for vegetable dishes, buko and fruit salad for dessert, tea, juice, and soft drinks for beverage, the question is, in how many ways can you choose your meals consisting of 1 cup of rice, 1 main dish, 1 vegetable dish, 1 beverage, and of course, your most favorite 1 dessert? So I will give you 5 minutes to do this. If you think that you still need more time, more than 5 minutes, then you may choose to pause the video, okay? So just feel free to pause the video. If I'm talking too fast, you can just pause the video, and maybe I will play a beautiful song for you, somehow energetic, so you can answer this one. And again, this would actually require the application of permutations and the fundamental counting principle. So I will get back to you after 5 minutes. Good luck.
I found a love for me. Darling, just dive right in. Follow my lead. I found a girl, beautiful and sweet. I never knew you were the someone waiting for me. 'Cause we were just kids when we fell in love, not knowing what it was. I will not give you up this time. Darling, just kiss me slow. Your heart is so light, and in your eyes you're holding mine. Baby, I'm dancing in the dark, you between my arms, barefoot on the bars. Baby, stronger than anyone I know. She shares my dreams. I hope that someday I'll share her home. I found a love to carry more than just my secrets, to carry love, to carry children of our own. We are still kids, but we're so in love, fighting against odds. I know we'll be alright this time. Darling, just hold my hand. Be my girl, I'll be your man. I see my future in your eyes. Baby, I'm dancing in the dark, you between my arms, barefoot on the bars. Baby, not knowing what it was. I will not give you up this time. Darling, just kiss me slow. Your heart is so light, and in your eyes you're holding mine. Baby, I'm dancing in the dark, you between She shares my dreams. I hope that someday I'll share her home. I found a love to carry more than just.
Alright, so how was the performance? Or how was the question that I created for our activity number 1? Did you find it interesting? So may I ask you the following guide questions that would help you realize what are the logic behind that activity number 1 entitled Recollection. So may I ask you, how do you find the number of ways as for each item? You can write it on a piece of paper, or you can leave it in the comment section, or you can message this to me. And also, what mathematical concepts or principles did you apply? The third one, how did you apply these concepts or principles? And the fourth one is, which situations above illustrate permutations and why, or how did you say so? And which situations does not illustrate permutations and how did you say so? Alright, now these questions or this activity number 1 is under our introduction. For the guide question, or under the category of what I know. So if you were able to answer these 4 questions or guide questions and you have answered the activity number 1, then that means that you have developed the mastery of those 2 important topics, which is permutations and fundamental counting principle. What does fundamental counting principle says? Once again, fundamental counting principle, it states that if there are p ways to do one thing and there are q ways to do another thing, that clearly means that there are p times q ways to do both things. Alright, now for the next subject or the next part of introduction would be, we will be answering the question here, what's new? So you might be wondering, you might be asking yourself, what's new? Anong bago sa subong nga lesson? Of course, you already have an idea what's new because we have printed that one in the front of your Meltry module, which is to illustrate combinations of objects. But literally, what's new? I will not give you the answer proactively. I would like you to develop within you the answer for my question by simply doing this activity number 2, and this is a lot of fun. Alright, now we're back to our second activity, activity number 2. This will further answer your questions about the difference between permutations and combinations by simply answering activity number 2, entitled Put Some Order Here. So I will give you 5 minutes to answer this activity. I have here 10 questions. All you have to do is just to determine whether that particular scenario or situation requires permutations or combination. Number 1, choosing 5 questions to answer out of the 10 questions in a test. Is it permutation or combination? Number 2, opening a combination of padlock or a combination of lock. Is it permutation or combination? Number 3 question, what about winning in a contest? Permutation or combination? With number 4, selecting 7 people to form a student affairs committee. Number 5, forming triangles from 6 distinct points in which no 3 points are collinear. Number 6, assigning seats to guests at dinner. Is it permutation or combination? 7, drawing a set of 6 numbers in a battery containing numbers, or in a lottery, containing numbers 1 up to 45. Number 8, entering the PIN number of your ATM card. Is it permutation or combination? Don't give me an ATM pin number, okay? I'm just setting a scenario wherein you will be the one to decide whether it's a combination or permutation. Number 9, selecting 3 posters to hang out of 6 different posters. And the last one is listing the elements of subjects of a given set. Alright, so I will get back to you after 5 minutes. Good luck!
Love me again. Love me again. Love me again, baby. కలలైనా కన్నీళ్ళైనా కన్నులలో మళ్ళీ రావా గుబులైన సంబరమైన గుండెలలో మళ్ళీ రావా మళ్ళీ చూసేవు మళ్ళీ నవ్వేవు నిన్న మొన్న చేసిందే మళ్ళీ మళ్ళీ చేసేవు చూపిన కోపాన్ని మళ్ళీ నాపై చూపేవు మళ్ళీ నన్నే ప్రేమించరాలేవా Love me again, love me again. Love me again. మనసారా
Alright, I'm back. So how was your performance in answering our activity number 2 entitled Put Some Order Here? I also would like to ask you the following guide questions. In which tasks or activities above is order or arrangement important? And give an example to illustrate each answer. Third one, in which activities wherein the order is not important, and give an example and illustrate each answer. After you were able to answer all of these questions or guide questions, did you know that by simply answering this one, you were able to identify situations that involves permutations and those situations that do not require permutation? And the latter would be our topic for today, which would be or which is combination. So you will learn more about this topic. Just stay tuned and watch the next few slides. Alright, now this time let's proceed with the next phase, which is development. So what I know, did you ask yourself what I know? So on this part, we will be bridging the gap. We will be bridging the two topics from the past or your previous lesson, which was permutations, and today's lesson, which is combinations. So I know that, let's establish first what you already know. Okay, I know that you already know what is permutation all about. You know that permutation is the arrangement of objects wherein the order is important. Just like you are setting up a code on a safe lock code that you set it up, like for example 472. So no matter how much you try unlocking it with the same digits but not in order, like 274 or 724, you know the fact that it will never work. Why? Because it must be the same arrangement that you have set it up with. So if it's 472, then it must be 472 because the order is important. Alright, and another example is if you were trying to log into Facebook and your password was actually ABC123 star, and suddenly you forgot what your password exactly is, but you know what those characters that you have set it up with. It's a new password, so barely remember what those are, but you know that there's 1 2 3, there's ABC, and there's a star symbol. So if your password used to be ABC 1 2 3 star, and then you try to log in and you keep on pressing 1 2 3 ABC star, you already know the fact that it will never work. So no matter how much you try, how many hours you spent there, it will never work because it has to be the same sequence of characters of the exact password. So you were trying to hammer the keys, but it will never work. And another one is, I know that you already have an idea or you already mastered what FCP means. What is FCP? You know, the FCP stands for Fundamental Counting Principle, that states that if there are P ways to do one thing and there are Q ways to do another thing, that means that there are P times Q ways to do both things. Let's say, for example, you have a friend, you would like to give him something. You have a collection of 4 novels and 3 cookbooks. So basically, you are planning to give your friend 1 novel and 1 cookbook. Alright? So on that particular situation, you have 2 tasks to do. The first one is to pick a novel from your selection. The second task is to pick a cookbook. So if you have 4 different novels to choose from, that means that you have 4 possible ways. Alright? Then if you have 3 cookbooks to choose from, that means you have 3 possible options or 3 possible ways to pick any one from the cookbook. So that is where this fundamental counting principle applies for. And here, you still remember that last time I have posted an activity which was taken from my first video lesson, illustrating permutation, wherein I posted there Fresh the Walker's video of finding out the code using this clues, wherein it says there that a number lock has 3-digit code. Can you crack the code using the following hints? 1 number is correct and incorrect position. That's from the 682. On the 645 clue, 1 number is correct but in the wrong position. This is getting exciting. Number 3206. 2 numbers are correct but in the wrong positions. 7 through 8, nothing is correct. 780, one number is correct but in the wrong position. So those are the clues, and you are asked, this is like a riddle of the brainy questions wherein you are being asked to unlock or crack the code. And there's one outstanding student of mine from 10 Estoy who actually had the courage to post her answers, and I even provoke her how did she got the answers. So let's give her a warm applause for doing a great job in her studies. For May Kyla Vingo, I'm very much impressed. So these are her answers. I asked her if you can see the message thread, or if you ever dropped by on that question or that post online. And I also encourage everyone to participate on answering activities, every activities that I'm posting, because it's not for me, it's actually for you. And I also wanted to encourage you to collaborate among your classmates, just giving a feeling that you are still in a classroom, you are still part of a group. That's why we have created this group chat wherein all of your classmates are in there. Alright, so don't be shy and don't hesitate to ask questions if there are some difficulties or challenges that you think you need some help with. Alright, so I'm open for that one. Regarding this topic of fresh walker, it's very exciting, and this questions about unlocking this 3-digit code, it's been popping up on YouTube. So I saw it while my kids are watching some videos, and decided to have this one and share it with you guys. Regarding this one, I know that every individual is unique, so we have different strategies in solving problems related to mathematics. And for me, upon solving this 3-digit code using the following hints here, I find it easy to start at 738 that says nothing is correct, because you know the fact that on 738 you can eliminate these 3 digits. So every clues in there that has 7, 3, and 8, that means none of those digits are part of the 3-digit lock code of this padlock. Then you can go back to the very first hint that says one number is correct on the 682, one number is correct and in the correct position. That means 8 is eliminated, so we got remaining 2, 6, and 2. So among these two, one of this, either 6 or 2, is correct. And once it is correct, you figured it out, then it is in the correct position. Alright, then you go back to the second clues that says 645. One number is correct, but in the wrong position. So what number comes again from hint number 1 to hint number 2? Only number 6, right? So that means there must be a correct number in there, but in the wrong position. So it can either be a 6, can be either 4, or it can be either 5. Alright, the answer to this one is actually 052. And she explained it very well, although we have different explanations, different strategies, but I'm so much impressed in how did she, or how Kyla aligned all her logic, her strategies, and which one she chooses first, which she find it easy to solve. It's not actually solving permutations and combinations, or this topic is very interesting. This one requires logic. It requires you to think, to analyze based on the given figures. So if you have developed that kind of skills, then everything will come smooth and easy to understand. So there's not much complicated. You can also use a calculator when it comes to solving for the combination or number of possible combinations for every given problem, because there are a number of sets or number of objects in a set that is quite big enough that you cannot count on your fingers. Alright, so what's in. What's in phase, we will be using the knowledge of the topics, permutations, and fundamental counting principle in order for us to fully understand what combination is all about. All right, and what is it actually? So this is the heart now of our topic of our discussion for today, which is combinations. So basically, how do you define combinations since it's different from permutation? So I know that you already have it in mind, you have answered your module about this. Combination is a selection of the possible arrangements without regards to the order in which the subjects are selected. So it doesn't matter the order here, whether the first object comes first or it comes the latter, because this is combination. Now, illustrating combinations is just the same as we are illustrating permutations. But before we get into that any further, since we are dealing with situations that where in the order doesn't matter, I know that you have done the activity number 2, wherein I asked you to label if it's permutation or combination, depending on if the order is important or not. So you already know that combination has it's a selection of possible ways or selection of objects in a set wherein the order doesn't matter. Now let me introduce to you, because one of the methods to illustrate combinations, aside from listing method, tree diagram, third one is formula. We will be using the formula for combinations of n objects taken r at a time is expressed on the following ways, wherein your NCR is the number of possible combinations taken r at a time, which is equal to n factorial over n minus r factorial times r factorial. So you already know this meaning of these letters from our previous topic or of permutation, wherein your n, your small letter n, is the total number of objects or total number of elements in a set or in a group. So that's your n. All you have to do is substitute the number into this given formula to these variables here. Then your r is the number of elements that you would like to take at a time. So r should not be greater than n, because we are picking just a few number or few figures out of the set. So it's always smaller than n. Then we got the exclamation point. You know that the symbol for factorial is exclamation point, so I have discussed that thoroughly to you last time. Your factorial can be expanded by taking one object or element from a set and pair it to the rest. Like for example, 4 factorial can be expanded 4 times 3 times 2 times 1. Alright, and then we got your, that's all. N, we have the meaning for n, meaning for r factorial, which is represented by the symbol of exclamation point. Now let's cite an example wherein combination is being applied. For example, you were given a task, you were given a project wherein you were asked to choose 4 among your classmates to be your group mates. Then you want to pick Ira, Belle, Charlie, and Dave. Now let me ask you, if you pick Dave, Belle, Ira, and Charlie, does it make any significant difference? Of course not, right? Because it refers to the same people in a group. So no matter if you mention first Ira or mention Belle or Dave or Charlie first, because your group will still be composed of the same number of people. But if you say you want to pick Jamie, Ira, Belle, and Charlie, now that is a different combination because we have a different person in a group. Now let's apply this illustrating of combinations in a practical way using the examples that we have here. First, we will be applying it through the use of listing method with the following problem given. You are asked to illustrate all possible combinations in the given set taken r at the time. We have 5 different people: Lara for the initial L, Justin for J, Anna for A, M for Max, and B for Boy. Alright, now our first example wherein we can apply this listing method. Let's say you are asked to illustrate all possible combinations in a given set here, taken two at a time. We have Lara, we'll just use the initial L, Justin for the initial J, Anna for the initial A, Max for initial M, and B for the initial O, boy. Now with the use of a listing method, all you have to do, since you are looking for a pair, you want to find out how many possible number of pairs that you can have out of this 5 people, from Lara, Justin, Anna, Max, and boy. So what you will have for the listing method, we have LJ, that's Lara and Justin. LA, Lara and Anna. LM, that's Lara and Max. LB, Lara and boy. JA, Justin and Anna. JM, Justin and Max. JB, Justin and boy. AM, Anna and Max. AB, Anna and boy. MB, Mesh Bubble. So Max and boy. So this is how we illustrate combinations of objects taken are at the time using the listing method. So it's the same as permutations, just that the order doesn't matter here. Alright, now let's proceed to tree diagram. Now tree diagram is somehow similar with just like we're putting an arrow or grouping them, just like you're grouping fruits. So let's proceed with the illustration here. Alright, now we are at for tree diagram. As you can see here, since there are 5 people in a group, Lara, Justin, Anna, Max, and boy, so we have their initials LJAMB. Alright, so using a tree diagram, if you pick one person, you can pair it to the rest of the 4, right? So let's start with Lara. Lara can be paired to the rest of the 4 people remaining in the group because there are 5 of them. So you put there an arrow. Alright, now after putting an arrow, so the illustration would look like this. Alright, so our illustration of combination using tree diagram based on our given problem would be this one. In our problem, we have 5 different people. So if we pick Lara first, Lara can be paired to JAMB, Justin, Anna, Max, and boy. Same with J. J can be paired to Anna, the remaining 4 people. We have positioned the first 2 people, so we only got 3 left out of 5. So Justin can now be paired only with the remaining 3 people, Anna, Max, and boy. Same with Anna. Anna has only 2 options left, 2 possible ways. She can pair herself with Max or boy. Then Max, since the 4 people already was positioned, so there's only 1 spot remaining, so Max can only be paired to boy. And that's how we illustrate combinations through the use of tree diagrams. So as you can see, we have limited number of objects in a set that is being represented by 5 people in a group. So that's why we can illustrate it right away. But if you have larger number of objects or elements in a set, then I would prefer you to proceed with the third method, which is formula. Now let's proceed in using formula, or the third method, in illustrating combination based on the same given problem composed of 5 different people. So if you will be using the formula for combination of n objects taken are at the time wherein your r is 2 people, because we are pairing them. So our formula is NCR or C taken 5. We have 5 as the number of objects taken r at the time, which is 2, is equal to n factorial over n minus r factorial times r factorial. Your n is 5, so substituting the value of 5 in a given formula, so your n factorial would now become 5 factorial over your r is 2 factorial, times 5 minus 2 factorial, which is your n minus r factorial. Then if we are going to expand it, 5 factorial, as I mentioned earlier, expanding 5 factorial, it will now be 5 times 4 times 3 times 2 times 1 over the product of r factorial and n minus r factorial. Now, as I have mentioned earlier, upon writing the problem, the formula, you can either write r factorial times n minus r factorial, or you can pick n minus r factorial first times r factorial on the denominator of your formula, because you will have the same result. So going back in our example here, 5 times 4 times 3 times 2 times 1 is your 5 factorial over your r. R factorial is 2 because our r is 2, so we got 2 factorial. But if you expand 2 factorial, that will be 2 times 1. And times 3 factorial, if you expand 3 factorial, we got 3 times 2 times 1, which is shown on the second to the last step. As you can see here, I have crashed out from the numerator and the denominator of the 3 factorial, because we have both 3 times 2 times 1 over 3 times 2 times 1, so we crashed out. What was left is 5 times 4 over 2 times 1. Now we got 4 divisible by 2, so we can divide 4 divided by 2 will give you 2. So what will be left is 5 times 2, which is equal to 10. So this one, I find it easy and fast in using a formula, whether you have a small number of n in a given set. So these are the 3 methods of illustrating combinations taken r at a time. Again, listing method, tree diagram, and formula of combination of n objects taken r at a time, which is n factorial over n minus r factorial times r factorial. So now we will proceed to the activity just to test or make sure that you have understood the topic. So let's just test your knowledge by answering this activity here on the screen. Alright, and for our activity number 4, I will give you 10 minutes to answer this, and once again, if you need more time, you can pause the video. So I want you to illustrate all possible combinations in each item below with the following questions, or using the tree diagram for this first problem. In how many ways can you select a committee of 3 students out of 10 students? The second one, I want you to illustrate all possible combinations in each item below by using the listing method. For this problem, if there are 12 teams in a basketball tournament and each team must play every team in the eliminations, then how many elimination games will there be? So you have to solve for the possible number of combinations taken r at a time using the listing method. And let's proceed to number 4. Number 3 questions for the activity number 4. Illustrate all possible combinations in each item below using formula. I have here the given problem. Mrs. Rivera's business is gown rental and sale, and she decided one day that she would display her 10 newest gowns in her shop's window to attract customers. If she only had 5 mannequins and planned to change the set of gowns every 2 days, how many days will have to pass before she runs out of a new set to display? Now for this one, just use formula. Alright, and I will get back to you after 10 minutes.
I found a love for me. Darling, just dive right in. Follow my lead. I found a girl, beautiful and sweet. I never knew you were the someone waiting for me. 'Cause we were just kids when we fell in love, not knowing what it was. I will not give you up is all I own, and in your eyes you're holding mine. Baby, I'm dancing in the dark, you between my arms, barefoot on the grass. Baby, stronger than anyone I know. She shares my dreams. I hope that someday I'll share her home. I found a love to carry more than just my secrets, to carry love, to carry children of our own. We are still kids, but we're so in love, fighting against odds. I know we'll be alright this time. Darling, just hold my hand. Be my girl, I'll be your man. I see my future in your eyes. Baby, I'm dancing in the dark, with you between my arms, barefoot on the grass. Baby, I'm on a Saturday night in the summer, sundown and they all come out. Lamborghinis and they rented Hummers. The party's on, so they're heading downtown. Everybody's looking for a come up, and they wanna know what you're about. Me in the middle with the one I love it. We're just trying to figure everything out. We don't fit in well, 'cause we are just ourselves. I could use some help getting out of this conversation. You look stunning, dear, so don't ask that question here. This is my only fear, that we become beautiful people. Top design, front row fashion. much last night and we made it nowhere. Now I see stars in your eyes when we're out there. I'm not fazed by all the lights and flash cameras. Cause with my arms around you, there's no need to care. We are just ourselves. I could use some help getting out of this conversation. No less stunning, please. Don't ask that question. This is my only fear that we become beautiful people. It's beautiful, it's bittersweet. You're like a broken home to me. I take a shot of memories and black out like an empty street. I fill my days with the way you walk. I fill my nights with broken dreams. I make up lies inside my head like one day you'll come back to me. Now I'm not holding on, I'm holding on. I'm less depressed that you're gone. Not holding on, I'm holding on. Beautiful mistakes I made inside my head. She's naked in my bed, and I will lie awake, making beautiful mistakes. I wouldn't take them back. I'm in love with the past, and I will lie awake, making beautiful mistakes.
Did me wrong cause I let you. Usually I like my situations beneficial. Doing something different, got me looking stupid. The only way I'm coming back to do is if you're dreaming. Lucid, prove it. If you made a promise, then keep it. Why you wanna lie and then get mad? I don't believe it. But really, I was doing just fine without you. Looking fine, sipping wine, dancing no club couches. Baby, why you wanna lose me like you don't need me? Like I don't block you and you still try to reach me. You just figure out how to call me from the TV. You running out of chances and this time I mean it.
I made inside my head. She's naked in my bed, and I will lie awake, making beautiful mistakes. I wouldn't take them back. I'm in love with the past, and I will lie awake, making beautiful mistakes.
And to test what you have learned from our topic, let's perform activity number 5. To summarize what you have learned in this lesson, please answer the following questions. Number 1, how would you determine if the situation involves combination? Just follow the same format. Number 2, how do you illustrate the combination of objects? And for your reflection, let's perform activity number 6. Journal writing. I want you to write your personal insight. Just impress me with your reflections about the lesson using the following prompts below. Same on your module. I understand that blank, and I learned that blank. So far, these are all the topics or all the lessons that we have tackled for the topic of combination and illustrating combinations in 3 different ways through listing method, tree diagram, and as well as formula. So next topic will be MELC 4 module, which talks about differentiating permutations from combinations. And we will proceed to our MELC 5, which will be solving problems involving permutations and combinations. So once again, this is your teacher friend Liz. Thank you so much for watching, and I hope that you have learned a lot. If you have questions, you can leave me a comment or send me a message. And have a great day.